Example number 5, we want to evaluate the integral from -2 to 1 of x cubed dx. So let's go back to the fundamental theorem of calculus part 2. First of all, let's look at the function f of x, which is the one inside the integral. We need to make sure this is continuous from the interval from a to b, and then we use the fundamental theorem of calculus part 2. It will be the antiderivative of the little f, which is big F, and we will plug in the b and the a. Okay, so that's what we will apply in this problem. So the function f of x is x cubed. So the antiderivative for this is the function big F of x is 1 over 4 x to the 4. And also that the function f of x is continuous, so we can apply the fundamental theorem of calculus. So we will get f of 1, which is f of b, minus f of a, -2. Then we plug into this function f right here. So we get 1 over 4, 1 to the 4th, minus 1 over 4, -2 to the 4th. So we have 1 over 4 minus 1 over 4 times -2 to the 4th is 16. And we have 1 over 4 minus 16 over 4, and it's equal to -15 over 4. So you can recall the section that we learned before. To find the area, we have to do a lot of things for this kind of problem, and it took like 1.5 pages to get the answer. We use the theorem number 4 in section 4.2, or we use the Riemann sum, the sum of the rectangles. And now we can calculate the problem really fast in like 2 minutes or 2 seconds. In example number 6, we want to find the area under the parabola y equal to x squared. The area means finding the integral from 0 to 1 of the function x squared dx. So the function f of x is x squared. The antiderivative for this will be x cubed over 3. And this function is x squared is continuous, so that's why we can apply the fundamental theorem of calculus part 2. So that would be f of b minus f of a, f of 1 minus f of 0. So we plug in, so we have 1 third minus 0 over 3. So the answer is 1 third. Example number 7 is also the same thing. We want to find the area under the curve cosine of x dx from 0 to b. So the function f of x equal to cosine of x is continuous function, and the antiderivative of the cosine is the function sine of x. Now we apply the fundamental theorem of calculus. So we will get f of b minus f of 0. So we will have sine of b minus sine of 0. Sine of 0 is 0. So we will get sine of b. Specifically, if we take b is pi over 2. So let's look at the graph first. You recall the cosine function. The graph is like this. So this is 2 pi, this is pi over 2. So if b between 0 to pi over 2, and if we stop b at pi over 2, which is the area under this shape right here, if b is at pi over 2, then we will have, if b is pi over 2, then we will have side of pi over 2 is given as 1. So that means the area under this curve is 1.